All right, we're going to continue looking at volumes by cylindrical shells. What we've looked at so far is that if you were to take um, some kind of uh, function here, so let's say this is our function, um, and we take a representative shell, um, meaning the shape right here from the x-axis to that um, function, that the height of that function is f of x. We're rotating around the y-axis when we've been doing these, and so if we rotate it around there, our circumference ends up being 2 pi r, or in this case, the distance from the y-axis to our shell, which would be x here, and so we get 2 pi x. And then if we were to take that cylindrical um, shape, shell, and cut it and lay it flat, we get this rectangle, and the volume of that would be that circumference, that's the distance around here, 2 pi x, times that height that we've been talking about, f of x. And the thickness of it would be our dx, our change in x, and so we would get a volume. And what we're going to do today is continue looking at those. And when you start dealing with two functions for your height, we've looked at that you subtract those just like you would with area to get that height of that. So it'd be, in this case, g of x minus f of x, because g of x is on top. And our shell right here would still have that kind of radius here for our circumference of x, and that's why you see an x here. What we're going to look at today is that might not always be x if the line we're rotating around doesn't happen to be the y-axis. So the first problem we're going to look at here is let r be the region bounded by these two functions, square root of x and x squared, and find the volume obtained by rotating this region about the line x equals 2. Now notice this line is not the y-axis. This is a vertical line here through the x value of 2. We're going to do this problem. I also, if you want, I included a link on Schoology that takes you to this Khan Academy video. That he does a pretty good job of explaining this too, so if you want a second way to watch this and get some other ideas, that's a good video. But what we're going to do is we're going to try this one out here and see what we get. So first, let's graph this out so we can kind of have a picture of what this looks like. So we got these two graphs, square root of x and x squared. The graph of square root of x is going to go through 0, 0. It's going to go through the line 1. If we put 1 in there, we would get square root of 1 is 1, so it'd go through 1, 1. If we put 4 in there, we'd get 2, and so it's going to look something like that. If we graph this other one out, x squared, 0, 0, it also goes through 0, 0. 1 squared is 1, so it'll also go through this point. If you put 2 in, we get a point up at 4, so it's going to be kind of this parabola shape going up. Looks like that. So the region that we're doing is this region in the between here, right? Taking this area right here. Okay, so usually on these we've been going around the x-axis, but now we're not doing that anymore. Now we're going around the line right here, x equals 2. So we're going to revolve it around this line of the line x equals 2. So how do we set up this volume? Well, our volume is going to be the integral. Our limits here we can see are going to be from 0 to 1 because that's where our region is. We're going to have, we need our circumference. So we got to figure out what's our circumference. We need our height. And we need our thickness here. And our thickness we know for sure here is going to be dx. Okay, let's actually go to our height first. We've done some of these now where we've had two functions. Our height should be the difference of these two functions, and we want to take the top one minus the bottom one. Well, we can see there that our top one is square root of x. That's the top function, and the one on bottom here is x squared. And so our height of this shape would be square root of x minus x squared. If we had some representative shell here, that's how the height of that shell. Okay, what about the circumference? Well, we know circumference is 2 pi times r. What is our radius? Now, usually we've been using x. Here it's not going to be x because the distance x is right here. That's a x value from our shell to the y-axis. We're not revolving it around the y-axis, though. We're revolving it around this line y equals 2. So our radius in this problem is this length. What do we call that length? Well, we know that that value over here is x. We also know that this line is at 2, and so this distance is 2. So what is that radius distance now? Well, that would be 2 take away our x value. And so in this one, our circumference ends up being 2 pi times the value 2 minus x. That would be our circumference. So if we integrate that, that would give us the volume of this three-dimensional shape using shell method here. Now, like we've done on some of these other ones, you can pull out the 2 pi because that's a constant. If you were going to go through now and solve this, what we would have to do is multiply this out and FOIL that out in order to show your work on this one. Now, remember when you're doing the multiplying here, you got to multiply first, outside, inside, last. So you'd have 2 times square root of x minus, we'll multiply the last ones, 2 times x squared, 2x squared. Inside ones would be multiplying a negative x into square root of x. We'll talk about how you can simplify that in a second. And then the last ones you'd be multiplying negative x and negative x squared. The two negatives would be a positive x cubed is what that would turn out to be. Now, if you were actually going to go through and do all this, kind of that long way by hand, and show the antiderivative, how would you want to think of these? Well, this would be the same as square root of x. Remember, is 2 times x to the 1/2, because squared is the same as power of half. This one's pretty standard. That last one's pretty standard here. What about this one where we got to multiply x and square root of x? Remember, this is like x to the first power. Square root of x is like x to the half, and when we're multiplying, we add the exponent. So that term right here would end up being minus x to the 3/2, which is the same as like 1 and 1/2. And then you could find the antiderivatives and so on. If you didn't necessarily have to show all your work, you could definitely use calculator like we've been doing. Let's use the calculator to find the answer here. But remember, if it's an exam question, make sure you then would go through and find this antiderivative and show your work, and then use calculator to check. But for time's sake, we'll use calculator here. So if we go math and do our integral here from 0 to 1, and there would not even be a reason to have to multiply that out if you were just doing that. I'm just going to enter it how we had there of the 2 minus x from the initial setup times square root of x. You got to hit the over to get out under that square root minus x squared. Close the parenthesis here. And don't forget to put in the x for your dx. And so that value, we get this amount as a fraction. I don't know if this, well, see, this is one downfall with using calculators. It does it sometimes can't always give you the exact value. It looks like to me this is trying to simplify this as 5.1666 repeating, and then they kind of doesn't give the exact value. So if we were to take that value as a fraction, it looks like we get 31 over 60, which is what it should be here. But remember, we still have this 2 pi to multiply it to. So if you multiply that out, 2 goes into this 30 times, and so we would get the answer, exact answer of 31 pi over 30 units cubed is the exact answer there. If you actually go through and find the antiderivative and do all that steps, that is the answer it should come out to be. All right, I want you to try to set up this one. So pause the video, see if you can sketch out a little picture, and then see if you can set up what this integral would be to find this volume. All right, let's see what you got. The picture of this one should look something like this. You got these lines here of square root of x, x equals 0, or y equals 0, which is basically the x-axis. X equals 4 would be a vertical line there. So you're getting this area here. We're rotating that around the line x equals -3, which is this vertical line over here. We're rotating around that. So if we take a representative shell, we want to figure out what we know all about that. Its thickness is going to be dx over here. The height of that is just the height of that function. Since the bottom is the x-axis, the height is just going to be square root of x here, because that's the function height. What is the circumference? It's 2 pi r. What's the radius here? Well, normally we would take this distance here as a radius if we were going around the y-axis, but we're not. We're going around the line y, or x equals -3. So what we actually need is what is that distance, because that's the distance to our rotation line. Well, what do we know that as? Well, that distance as x, this distance is 3. So what's that total distance? That distance would be 3 plus x. And so on this one, our circumference is 2x times the radius of 3 plus x. So that should be the integral from 0 to 4, because that's that is the x values here from here to here. And so to integrate this one, we can pull out our 2 pi constant there. Yeah, 4 is 0. Let's actually go through and do this one. So here you'd want to distribute this height to both of these. So you're going to have 3 square roots of x plus x times square root of x dx. Keep going here. We want to make this easier to find the antiderivative of. And so this is going to be the same as 3x to the 1/2. And this one would be x to the first times x to the 1/2. So that would be like we had in the last problem, x to the 3/2. Antiderivative, we want to go up a power. And so this is going to be x to the 3/2. Reciprocal would be 2/3. And we still got this times 3 here. The second one, we'd want to go up 1, so that'd be 5/2 with the reciprocal of 2/5. We want to integrate that from 4 to 0. Doing some simplifying here. These 3's would cancel, so we got just 2 times that. So we're going to end up with 2 times 4 to the 3/2. And plus 2/5 times 4 to the 5/2. Minus what we get when we put in 0, but if you put in 0, it's all just going to be 0. To keep simplifying here now, 4 to the 3/2, that's like square root of 4, which is 2 to the 3rd power, which is going to be 8. And so this is going to end up being 2 times 8 plus 4 to the 5 halves, that'd be like square root of 4, which is 2, and then 2 to the 5th power, which is 32. If we keep going here, that's 16 plus 64 fifths. And then we want to times that by 2 pi to get our answer. And so that would be a good place maybe to start going calculator here. Got 16 plus 64 fifths. And we want to times that by 2 pi. I'm not going to put the pi in there. We'll just put the pi right with our answer. And as a fraction, we get 288 over 5. So our volume here is 288 pi over 5 units cubic. And if you did it with calculator, you should have gotten that same answer. So that is using shell method when your rotation line is not the y-axis. So then you need to adjust what the radius is on your circumference.